Hi, everyone. Welcome to today's keynote. I'm really happy, really honored to be able to introduce our keynote speaker, Keith Holyoak. Keith holds a distinguished professorship at UCLA in the Department of Psychology and recently concluded his term as the editor of Psych Review. To say it plain, Keith is a giant, and the list of his impressive distinctions and field-altering contributions is far longer than I have time for here because we'd all just rather hear Keith's talk. But I do just want to mention that quite genuinely, Keith is my academic hero. And if they made action posters of academics, I'd have a poster of Keith on my wall. And it's not just that his work was the primary inspiration for me in deciding to become a researcher, though it was that. And I know it was that for a lot of other people. It's because Keith is the kind of academic that I think so many of us who are drawn to creativity want to be when we grow up. And I think that might have something to do with never actually wanting to grow up. But Keith has managed that truly rare balance of brilliance in science with artistic excellence outside the lab. Keith is a highly accomplished and widely published poet. His work is beautiful and thought-provoking, funny in all the right ways. And for those of you who only know him as the defining figure in the field of analogy, which he is, I hope you'll also go out and get one of his books of poetry, or perhaps his recent book, The Spider's Thread, that explores the neurocognition of poetry. Anyway, today we're lucky enough to get to hear his thoughts on creativity and analogy, and I just can't wait. So let me hand it over to you, Keith. Welcome, and take it away.
Thanks very much, Adam, for the flattering introduction, and happy Friday the 13th to everybody. We're always more creative on Friday the 13th. So I want to spend the next half an hour or thereabouts essentially trying to connect analogy with creativity, running through generativity, as the title suggests. And it's going to be a bit of a high-level sketch. It sort of starts in philosophy and ends in artificial intelligence, and we'll pass through a little psychology and neuroscience along the way. So let's start at the philosophy end. What is creativity? So many people have kind of tried to define it. I'm sure everyone here is familiar with the basic ideas. I sort of adopted specifically Maggie Bowden's discussion, who I've always found her to be the most interesting philosopher of creativity. And she says it's essentially the ability to generate ideas or artifacts that are new, surprising, and valuable in some general sense. Now, as I'm sure you know, each of these terms is fuzzy and open-ended and has elements of subjectivity. So what exactly is new? New to who? New to humanity or new to the thinker at the moment? What exactly is valuable? And is that really the key to creativity? So you can get extreme cases. So perhaps Van Gogh, since he was underappreciated in his lifetime, was not very creative, but then after he died, he became extremely creative, which seems odd, at least. Particularly, what is actually the difference between new and surprising? So Bowden actually discusses, for example, Chomsky and others who've claimed in general terms that the use of language is creative. And in some sense, it is, in the sense that you can generate novel sentences that nobody else has ever produced before. But Bowden argues that that isn't really quite what we mean by kind of real creativity. And the general idea that comes out of it is that at least part of what makes something creative has to do with the mode of generation. How exactly did it come about? And what that implies is we can't totally decide whether something is creative just essentially by looking at the product. We have to know something about its origin. So here's kind of an extreme example of that. Here's a couple of pictures that purport to be a self-portrait of Van Gogh, done in Saint-Remy in 1889. As I'm sure you know, Van Gogh did a lot of self-portraits. So I wonder which of these is the real thing. Was it Van Gogh in his blue period or his green period? The one on the right in green is the actual painting. The other Van Gogh was done by John Myatt last year. John Myatt is an interesting figure. He's considered the greatest forger of the 20th century. He started off, he just liked to reproduce the paintings of famous people. Then somebody started passing them off as the originals, which caused some trouble. But in more recent years, he's done very well as a reproductionist. In fact, the blue Van Gogh here, I saw on the internet for sale the other day for $35,000, which is, so it is valuable. Of course, it's not as valuable by 100 million plus relative to the original Van Gogh. Now Myatt, you could say, well, he is just copies, so that's certainly not creative. I kind of like his own quote about that. When I paint in the style of one of the greats, I'm not simply creating a copy. Just as an actor immerses himself in a character, I climb into the minds and lives of each artist, adopting their techniques and search for the inspiration behind their view of the world. Then and only then do I start to paint a legitimate fake. So I think we could roughly say, well, John Myatt is certainly not super creative, but he certainly got skill. And you can in fact see in this quotation, of course, it actually alludes to the method acting as a technique. There's something about even imitation that has a sort of a quality of generation by trying to imitate the process of generation as opposed to just the product. I thought I'd throw this out from AI. Some of you have probably seen this because it's pretty famous now. It was just the last year or so that a system called DALL-E, which is a variant of GPT-3, one of the largest current natural language programs, has been trained with huge amounts of data to turn phrases into drawings. And so given the phrase an armchair in the shape of an avocado, here we see some of its renderings, which at least on first impression, I would say are pretty interesting and unexpected from a computer program. Is this creativity? So I would say at this point, we have to defer judgment until we know something more about the process by which these came about. In general, what I want to argue is there's sort of two modes of generation. These are really a continuum, but take the extremes. In the routine method of generation, you have a closed set of inputs, some specialized procedure that applies to it, which produces an output. And such routines could range from, let's say, addition, which are your numbers of the input. Addition is the specialized operator, it gives you the answer. But it could also include the product of associative learning, where you've learned specific connections between specific inputs, which can lead to, in fact, novel output, but arguably not really creative. On the creative side, the input becomes an open set where we couldn't say in advance what might possibly feed into this system. And what's being used to operate on is some general procedure, but not just any general procedure, because it could be just, random, some kind of random process, but rather one that's guided by certain constraints. And this kind of procedure has at least the potential to produce a kind of surprising novel input. And what I want to argue is that analogy is at least a potential general mechanism for creative idea generation. So an analogy in a nutshell, some source analog is used to alter the representation of a target. The input can be open-ended because there's no real constraints on where this source could come from, which is, part of where originality comes in. And then analogy is a general procedure for making these inferences with certain constraints, which in the analogy world are talked about a lot. Roughly speaking, we're trying to match elements so as to maximize the similarity of the entities and the relationships between them, especially for the important ones, and favoring one-to-one mappings in the ideal situation. So analogy doesn't have to be creative. It can be pretty mundane. But I want to argue in the rest of this talk that idea generation, specifically based on semantically far analogies, is potentially a key mechanism in creativity. And I kind of want to get into why it's the far analogies and the generation of the far analogies that is particularly special. So first, a few examples that kind of look like analogy at work in actual creative generation. I always like Velcro. George de Mestral, back in the early 40s, was walking his dog and he got caught in some burrs and was interested enough to look at the little hook mechanisms which caused them to connect and reconnect to dog fur. And after actually a dozen years or so, he had invented an artificial version of this that became Velcro. Another example, a week or so ago, I actually got a dental implant, and it turned out my dentist is Swedish originally, and told me the story of a Swedish orthopedic surgeon, Dr. Per-Ingvar Brannevark, not a dentist at all, who was experimenting on ways to heal bones, and he put a titanium into a rabbit femur, left it a while, and came back and found he couldn't pull it out. And again, interested in this anomaly, he discovered that titanium, for some reasons, is peculiarly good at attaching itself to bones. And after a dozen years, it seems it often takes a long time to make the full implications realized, he actually invented the early dental implants based on titanium, which is still used today. And finally, a more perhaps abstract one, analogy, Rene Descartes supposedly liked to lie in bed in the morning just thinking. And one day he observed a fly meandering around on his square-tiled ceiling and had the thought that, well, wouldn't it be interesting to be able to define exactly what the root of that fly is? And with a little thought, invented Cartesian coordinates, which, of course, he added extra wrinkles like let them run infinitely long in each direction and introduce negative numbers and so on. But the basic idea was there. So these are the big examples. But I guess if we take seriously that it's the mode of generation that in some sense matters, that kind of gives us a license as experimental psychologists to work on sort of smaller scale analogies, which at least arguably may illuminate the mechanism that ultimately leads to some of these large scale creative products. So now I want to turn to work by Adam Green, along with David Kramer, Jonathan Fugelsang, Jeremy Gray, and Kevin Dunbar. Adam mentioned that I influenced him, but he influenced me at least as much, I would say. This group created a set of verbal analogies, kind of a typical format for psychologists to use and psychometricians. Blindness is to sight as deafness is to hearing. And designed them to be either semantically close, as in this example, or far. Blindness is to sight as poverty is to money, where we jump to a very different domain. Besides varying semantic distance, another interesting aspect of these stimuli is that they were kind of idiosyncratic and eclectic. That is, rather than having sort of batches of the same relation reappearing, each one is relatively unique, which I think makes them particularly interesting for connections to creativity. So anyhow, Adam and his gang measured the neural response that occurred as people solved these. First of all, in a verification mode, get them like this and say yes or no. There's some false ones thrown in, and identified a particular left frontal polar region which responds more strongly as the semantic distance increases. And of course, as you might expect, the FAR analogies are harder. They take a little longer to solve, more errors, but they sort of carefully did statistical controls to rule out the kind of difficulty in general as the factor, honing in on semantic distance as being the critical one. A couple of years later, the same group turned the same stimuli into an analogy generation task, which is why this is going to be nice materials to compare verification and generation. So now it's the same thing. Blindness to sight as poverty is, but now there is no D term. The participant is supposed to look at this and make it up, push a button when they've got the idea in mind, and then they get feedback on what the answer is. And basically, you got the same pattern, same general frontal polar area responds in a graded parametric way to semantic distance. Now, in fact, at this point, from the neural point of view, it isn't obvious if verification and generation are different. These are different experiments, different participants. So no, as far as I know, no one has like literally actually compared carefully between the two. But in fact, when we go over to behavioral studies, we find there are some differences between verification and generation. So my student Michael Vendetti and us, a couple of years after Adam's second study, had the idea to take the 4 cells, either verify near or far analogies or generate near or far analogies, and do it between subjects. So any one person just gets one of those pools of examples, and then afterwards transfer them to a different analogy task that looks a lot different. This is a stimuli from Markman and Gettner. You get a little picture, you highlight one of the elements, and you're asked, what does this go to down here? And they're designed to be ambiguous, so the umbrella could arguably match the other umbrella down here because they look alike. But there's a more relational response, which is, well, it's the newspaper, because in each case, they're functionally being used the same way to protect from rain. And as you can see, among the 4 conditions, the one that stands out was generation of far analogs, where we got a significant boost in relational responding in this apparently unrelated task. Another interesting little detail was that for the generation task, we measured fluid intelligence with the Raven's progressive matrices, which is a standard tool. It, as usual, predicted relational responding, but only for the near group. When you gave the far generation task, it actually seemed to abolish the impact of fluid intelligence, roughly as if you have high fluid intelligence, you sort of, as a trait, tend to think relationally. But if you give this boost, then you essentially have created a relational mindset, which is like a state relational processing. Now, in the years since, there's been several studies that have done some replications and extensions of this. Three of them, Chaxel, Andrews, and Boho-Adana, and Goldwater and Jen Mrazek, literally used the same Green et al. Stimuli, the far analogs, to show they increase information distortion, which actually happens when you put a lot of relations together. Improves performance on complex linear orderings. And this study also actually showed that you eliminate the impact of fluid intelligence when you add the generation. And Goldwater's group showed that exposure to far analogies and generation increases relational encoding on other problems and hence better analogical retrieval. Nina Sims and Lindsay Richland using other age-appropriate materials showed that essentially you get the same effects for 4-year-olds. That generating rather than being told relations increases relational responding on a subsequent task. One other interesting example, and this is from Christine Cheeseborough and with her advisor John Chunios, and I sort of hang out with them too. Just yesterday, I did a presentation of another version, also originally based on the Green et al. Stimuli with some extensions. She had 2 sets of triples. They either are all near analogs, steering wheel, rudder, boat, handlebars, bicycle, or what she calls expansive, where the first 2 are the same, but the third one, voting government, is kind of moves to another domain. And what you did with this is kind of like tying it to creativity. You give the first 2, which are 2 near analogs. You ask the person what do these things have in common. So actually, what they're generating is the relation itself. Then a third pair comes in, and it's either another near one in the consistent or a far one in the expansive, like voting government. And you ask them again, what's the concept the analogy represents? And then you got ratings of difficulty and confidence and so on, and also ratings from observers who read these, what the answers, how much conceptual change actually went on here. And what she found is those expansive sets where you've shifted to the far analog as you generated the relation that links everything, got more of the aha experience, like a sense of insight, which of course kind of goes with a kind of sense of surprise, and also greater conceptual change in what people actually said. Let's return to this basic idea that there's 2 modes of generation. So if we specifically talk about semantic analogies, the 2 modes of generation that come to mind are somehow using verbal associations, like existing semantic connections between the terms that you're given to activate a new D term, or some kind of true relational reasoning, where, in other words, you calculate the relation between A, B, transfer it over to C, and then use that to generate a kind of ideal or approximately ideal completion that would be close to some D term that you could actually produce. And kind of the specific version of my overall hypothesis here is that while verbal associations may be sufficient to generate solutions for near analogies, it isn't enough for far analogies, and that's why the relational reasoning kicks in, especially for the generation of answers to far analogies. So just to make this slightly more concrete with our standard example here, if I have a near analogy, blindness to sight is deafness is to hearing, and you just sort of plot out what are plausibly the entering associations. Well, blindness goes with deafness and sight goes with hearing, the target you're trying to get to. And the relation between the blindness sight is basically the same as relation between deafness and hearing. So there's a whole lot of long-term knowledge that could effectively be used to help generate this missing D term. Whereas if we take the far analogy, that's just not true. There's basically no particular link between A, B, and C, D. Even the relation isn't quite the same. That's kind of why you get this conceptual change. So blindness is a loss of sight. Poverty might be the loss of money, but maybe you were born poor, and it just means you lack money for whatever reason. Now, in the current AI world, as I hope you probably have at least heard about in natural language processing, there are many now models called large language models, such as GPT-3, which I alluded to earlier. And their whole job, what they do is to take a linguistic string of sentences and essentially predict some missing item. So the one I'll talk about is called BERT. It's a very famous one, but bidirectional encoder representation from transformers. And it works basically like this. If I gave it an analogy, blindness is to sight, just as poverty is to, and a blank, and what it does is it takes representations, entering representations of each word, which are called embeddings, moves them through a feed-forward network, which is called a transformer network, because what it's basically doing is using the associations between the words to change the representation of each one till you get up to the output level. And then based on that, you can use those associations to predict the answer. So that would be a very sophisticated realization of a kind of verbal-based associative model for generating D terms. An alternative is a system that actually does relational reasoning. And I'm going to focus on one our group has developed. It was Hanjing Liu leading it, called BART, Bayesian Analogy Relational Transformers. And it's just an accident that Bert and Bart sound alike, but they have nothing to do with each other. Bert is very famous and Bart isn't. What Bart is trying to do is to take a semantic space of individual words, and we pull them out of yet another deep learning model called WordDivec, a little older than BERT actually, which will tend to put, for example, the people together and living things or non-people together and so forth. And what BART's trying to do is change it into a new relation space, which is based on pairs of words. So there's things that contrast, like girl, boy, but also hot, warm, which weren't alike a priori, but their relation is alike, and so on. So how does this work? So I'm not going to try to go through the whole story of the learning process, but because actually for the present purposes, I mostly just want to talk about what is learned. But the way the BART works is it takes examples of pairs. So suppose I'm trying to teach antonym as the relation R up here. So I give a bunch of examples of positive and also negative examples. Not a lot. Usually we work with on the order of 20 positive examples and maybe triple that of negative examples. So basically we have an embedding that is a long feature vector. Actually it's 300 length, which we get from WordDivec, for each of the two words put together. Then the internal mechanism, it actually augments the feature vectors by some processing, which I won't go into for right now, which expands it. And then we use some statistical learning with the constraint of sparsity, which basically shrinks this down. So essentially selecting just the features most predictive of the relation and learns a weight matrix, which then predicts that relation. So the main thing I want to point out is that because of this color coding, that all the way through, there's the elements of the first term, and which are red all the way through, and the elements of the blue term all the way through. So they don't get mixed up. Essentially, what BART's doing is taking representations that are not relational, features of individual words, and creating this weight matrix, which ultimately predicts the probability that antonym holds here. And so that weight matrix becomes the sort of proximal predictor. And notice that it also is color coded. We can distinguish which weights come from the first term and which weights come from the second. So armed with that, we do that. BART learns a whole lot of relations. In the original model, it was 79. We now usually work with 270. But the basic idea is for each of these relations, whatever they are, similar, contrast, category, membership, and many others, we relearn a suitable weight matrix for them. And what that means is that now I can take any two words and represent the relational connections between them as a vector in the new relation space, the probability that it's an antonym, the probability that it's a category member, and so on. And armed with that, we can actually come back to, among other things, the green analogies that I've talked about before. So for any pair of words, like say blindness, sight, we get a vector of relation probabilities, where here the lighter bars are ones that are high, the blacker ones are ones that are low. And if you want to see whether some CD term like deafness, hearing is or isn't an analogy, you can calculate the cosine distance, and the lower it is, the more similar the two vectors are. And I don't know if you can see in this thing, but you can see there's like black bars here, a very strong matching thing here. These two are actually pretty similar. The next line, we have poverty money, which would be a far analog to blindness sight. And again, I'm not sure you can see, it's similar, but no, it's not quite as good a match to AB, but it's not bad. It's got a lot of the same things. Down here, I got wall paint, which would be an unrelated distractor. It's related, but it's a functional relation, not of a different sort. And actually, it matches very badly back to AB. And essentially, the near analogies are relationally closest, the far a little further, and then the foil is less at all. So we've shown that you can solve analogies that way. We also showed just along the way, and some work Jeff Chang did, that Bart's predictions about how similar an AB relation is for any AB predicts semantic similarity from representational similarity analysis, particularly in areas in the parietal lobe and the interparietal sulcus, suggesting some connection to neural stuff. So in our recent work, which I'll kind of end with here, we've now taken the BART model and used it for generation. So what I told you about so far is how BART becomes a model of analogy verification. But what we're really aiming at is to try and distinguish, well, what is the same and what is different if we ask the model or a similar model to start generating a solution. So you can start with just a single pair of words and a relation between them. So for example, let's suppose Bart has learned is a type of is one of its relations. So now I can give Robin and a blank and ask the model to come up with something that would be a good completion of this, simply of this pair. So this is where it becomes important that we have this strong distinction between the information that flows from the first term versus the second, because this is what we've got. We know it's a Robin. We want to create something that will make this is a type of relation true. In other words, we're taking the Robin information that Bart can work with and creating a representation of some hypothetical D, which in fact, ideally will turn out to be a lot like, say, the word bird. So I'm not going to go deeply into the math. It's a Bayesian model. So we're basically trying to predict the features of some best possible D from the known relation is a type of, and the known C term here, as I'm calling Robin, which means that it's proportional to the likelihood of getting that relation for certain features of D with the prior probability of how likely is D given C. And importantly, we make this highly prefer similar Ds to C, because relations in general are within the same domain. So we're looking for something that's related to Robin, and this sort of tells us that that's a constraint to use. Now, how could we generalize this to analogy? Essentially, it's kind of the same thing, except instead of just having one relation, we have that whole suite of relations in the vector. So this red stuff is exactly the same as the previous slide. Now we're looking for the best D given that we know C and A and B. So we just sum over all the possible relations, scaling it by the likelihood or the probability that that relation actually did hold for A, B. In other words, we're going to strongly emphasize those relations that appear to be true for A, B. So how are we going to do analogical inference then, just sort of stepping through it? So now we've got two models, BART Gen, which is the relational reasoner, and we've got the BERT model as a representative of the associative verbal learning. So what BART Gen is doing is we take the AB term, blindness, sight, and we calculate the probability of each of various possible relations that might hold, and so on. Then we come to the CD term, say poverty, where D is unknown at this point. And for each of those relations, we've run the little math we just looked at to calculate the probability of what's a good D that would produce that relation, multiplying it by the probability that it actually held for AB. So that's where these numbers come from. Ultimately, that gives us the answer when we essentially take the weighted average of all these possible Ds to produce the result. Meanwhile, BERT is doing what we talked about earlier. It's just going to take the analogy, blindness is to sight, just as poverty is to what, run it through, and using its learned associations between these words, attempt to predict the answer to the analogy problem as its completion. So here's some human data actually collected by Peterson, Chen, and Griffith using Adam Green et al.'s analogies again. Now, here's what's being plotted is for each model, how close was their the most frequent response they would generate to the human ranking. So low is better. So do you match the human ranking? And it's on a, notice it's on a log scale. So Bart beats Bert, both for near and far. But for near, not by so much. Bart's getting, like the 5th or 6th human response versus the 16th for Bert. By the time we get to far on the log scale, this is really far off. Basically, these, if you looked at the actual answers, they don't make a lot of sense. Particularly for far analogies, in generation, the purely associative kind of model does not seem to work. So just to sum up, what I'm arguing is creativity is defined in part by the mode of generation. An analogy is a general mechanism that's applicable to open-ended inputs and therefore enables high creative potential. Generation of solutions to far analogies is especially likely to demand intensive use of relational processing. We are not only, in essence, calculating the relation between a particular pair, but then you're using that knowledge to actively compute the best solution to a missing term. And that, in turn, appears to trigger a relational mindset, which means you tend to do more relational thinking, at least in the near term, leading to some of those transfer effects that I mentioned. So thank you very much for your attention, and mention of some of the main collaborators in the work that I just went over.
Thank you, Keith. That was quite a journey through some, I think, really important and also, work that's quite relevant to a number of the questions that have come up in the conference so far. So there are questions that are starting to come in from the group, but I want to steal you first and just ask about so one thing we like to fight about, although we don't fight that much in the creativity community. I think that's a problem we have. This is something that I was discussing with some folks in Gather yesterday. But one fight that maybe we do have is kind of the relative importance or the relative positions of the constructs of divergence and convergence. And I think your work, especially, the work related to the more semantically distant analogies, I think it leads to the question of how do you see kind of the interplay of divergence and convergence within analogy broadly and within the way that you've modeled it?
Right. I mean, broadly speaking, I think creativity depends on both. So it's not like is one better than the other or something like that. Like if you specifically look at the BART-GEN model and what it's actually doing, I think you could say it's divergence followed by convergence. So the divergence is that the way BART is representing the relation between any two words, which could be two words that never seen together ever before, such as blindness, sight. In fact, one of the interesting things about your stimuli is because they're not the relations that BART has been trained on. BART never got trained on lack of or loss of or anything like that. Right. What it does instead is use this distributed representation over many relations. So it's because it computes this detailed representation that's very divergent. Like, to what extent is this an antonym? To what extent is this a synonym? To what extent is this a category member, a function, etc.? That becomes its entering representation, and that's what then drives the generation of the D term. But in doing so, of course, it's converging, right? I mean, the final answer emerges exactly because it's the one that kind of answers what may be rather weak calls from multiple relations, saying, okay, I think it's sort of like you, at least a little bit, but a little bit like you. You put all that together and you have this kind of weighted average. So, so from the divergence comes convergence.
All right. Well, that's that's an answer that's quite diplomatic. It's also probably the right answer and a sensible answer. So I'll see if I can start a fight with this next question. So you refer to analogy as a general mechanism for creativity. To what extent would you say that analogy is the basis of creativity? Generally or universally, or is that not the claim? The claim is that it's just a flexible mechanism.
Yeah, right. I definitely do not want to be an analogical imperialist about this, right? I mean,
I didn't think so.
Yeah, I mean, especially to this audience. I mean, creativity has many aspects. I mean, in fact, the little anecdotal examples I was starting with had the invention of Velcro and dental implants. It shared the property that it was about 12 years from the original observation to the useful product that eventually came from it. Obviously, a lot of stuff happened in 12 years. And I mean, of course, part of that is that, in the standard sort of stages, Wallace's stages of creativity, that's the sort of final checking, although it's more than checking. It's like, working out all those details. But I don't even think analogy is the only trigger, certainly not the entire trigger, nor, of course, do I think it's even, in fact, only a cognitive process. The motivational element is important, although I think there may be a link between this notion of relational set that I was emphasizing and what you might think of as motivation, or at least kind of a propensity to kind of look somewhat deeply at information as opposed to staying just on the surface of it, which I think might be a broad thing that has an impact on the probability of being creative.
Yeah, well, I'm just inclined to agree, but yeah, I guess we won't have sparks, and I guess I'll just have to accept that. You're not taking the sort of Hofstadter approach that analogy is really the only thing that matters.
Oh no, I mean, if you want to have sparks a little bit, I mean, honestly, I tend to be the conservative analogies. I think Hofstadter's notion of analogy is so broad that if you just get totally confused about two things and you can't tell them apart, then suddenly you've drawn an analogy.
Right.
I don't think so. I think of analogy as being a very sophisticated form of similarity judgment, but it's not the same as all similarity judgments. And it's not the case that all previous experience runs through analogy. I mean, take, now the existing example of the natural language processing models. They're not using analogies, not even when they're doing analogies. They're using an extremely dense network of verbal associations that they acquired from looking at literally billions of examples and producing, actually billions of parameters to actually to do stuff. So there's lots of ways of using prior experience that aren't analogy at all.
So that's how Bert and Bart do it. And as this is a transition to the questions from folks who are in the audience. So Maxie asks, so do you think the Bart-Gen Bayesian algorithm has some kind of real world relation to computations that neurons in the brain, for example, in frontal cortex, do to find far analogy relations? So we've talked about how AI does it. How do you think the brain is doing this? How much do we know there?
I mean, okay. If we say we, I want to be careful because some people probably know something. I don't feel I know very much. People who've looked at the model have said, well, geez, this is like so much computation here. You're calculating all these different relations and so on. I think I would go as far as to say it's not neurally ruled out, because each of those computations of a relation in principle can be done in parallel. It's kind of like imagine the brain, which has classifiers that identify objects of all sorts, which we could agree. It's also got classifiers that'll identify relations of all sorts that it's been learned on. And each of those classifiers can potentially run in parallel. So we're not like literally walking through this with a bunch of conscious attention. Part of what it is acquiring kind of a rich verbal knowledge is in fact acquiring classifiers that allow you to look at a pair of words and in parallel work out many little mini relations that hold between them. So I guess I would say as much as I don't know any reason to think that it's not possible to realize a Bart-Gen style model in the brain, but we're certainly far from doing that. And we've tended to, work with Bayesian math because to a first approximation, we just want to get the job done and worry about how it's, could be implemented later. In our lab, some of our people are more neurally oriented and are producing like similar models using neural network architectures more directly. So I think it's possible and obviously kind of an interesting way to go to turn it into more computational neural models and then ideally find them in the brain. I certainly wouldn't want to say it's the frontal polar cortex in the end. I mean, I'm almost sure it's not only that, although maybe it's involved. As I mentioned in passing, to the extent we've looked at where in the brain it is sensitive to the kind of the similarity matrix that a BART model would predict, it's actually parietal cortex where, that's basically looking, well, what happens when you look at a single relation? I'm just looking at A, B. Now, when I give a CD and say, is that analogous or not? Indeed, the frontal polar comes in as well. But it's a system, obviously, not really like, one area is somehow doing the whole thing.
Yeah. Well, I mean, I can't even find anything to disagree with. So I guess we're not going to have an argument there. But yeah, I think that the notion of at least that sort of basic bar of is this neurally implementable is important for something that if you're claiming that it's relevant to understanding the brain as opposed to just, hey, what would be the
yeah, absolutely,
you could invent any way to do an analogy, what would you invent? And then right, I mean, I think the role of parietal cortex, we always see parietal and we sort of interpret it in a similar way. And I do think maybe there's some interesting mapping there between what the broader creativity literature tends to think about in terms of the back of the brain and the front of the brain in terms of the menu and the palate and those kinds of things, and perhaps the bit more divergent ideation and convergence in terms of integration. So food for thought. Thanks, Keith. This was really, really great. I appreciate you joining us. And I know there are other questions. If folks want to catch Keith, he may or may not make his way over to Gather, but you can, I'm sure, send him an email and he'd be happy to answer questions.
Yeah, definitely happy to follow up with anybody if you want to make contact.
That's great. So then for everyone heading to the poster session, that is in Gather, and that's got its own room for poster session 2. There's a portal there, or you can wander around till you find the door. And thanks again to Keith, and see everyone at the poster.